Alright, welcome back. So we're going to be talking today about experimental probability. Now, sometimes an event and whether its probability is known is necessarily clear. Sometimes we have to use an experiment or estimate how this probability is going to go in order to come out with a rough idea of whether it's going to happen or not. Now, in our first question here, we have a coin is flipped 60 times. And when we're talking about coins, you might say the probability is 50% chance it lands on heads and a 50% chance it lands on tails. That's its theoretical probability. But we also know that sometimes certain coins are shaped differently or weighted so that one side has a different chance of occurring. So this experiment might be looking at how we can assess whether or not a coin might be weighted to be more likely to hit on one side than not. Now we've performed the experiment 60 times, and in this table we get our results. So we have our heads, we have our tails at 26. Now, what is the experimental probability of landing on heads? So, when we talk about experimental probability, we would say that experimental probability is equal to the number of times an event occurred divided by the number of trials. Now that sounds complicated. It's pretty simple. In our first example here, if we're looking for the experimental probability of landing on heads, well, that's just going to be equal to the number of times the event we're interested in occurred, which is 34, divided by the total number of trials, which is 60. And that's our experimental probability. Now, we can simplify this further if you want to. You can reduce this whole thing down if you feel like it. Now, ultimately, when you're doing something like this and you're saying that is now the reduced probability or the simplified probability, it's as useful sometimes when we want to get it down to an easier number to work with, or we want to have a better idea of what its likelihood is in terms of smaller numbers. Alright, so let's move on. So that was B. A was just creating this. You can do this yourself, flip a coin as many times as you want and just see what happens. So the idea behind this is that we would expect the probability over a large sample of trials to revert to very near or exactly the theoretical probability. How does this compare with the theoretical probability of flipping a coin? So the theoretical probability of flipping a coin is 1 over 2, right? Or it's 50%. And we can put that in the same numbers as this. So this is the same as 15 over 30, or it's the same as 30 over 60. And what we can see is, compared to our theoretical probability, what we have is that the experimental probability, the chance of getting heads, is higher. Now this could be two reasons. Either there's something wrong with the coin, or ultimately we just haven't done enough trials. Alright, here's another one. So we have a spinner, and it's got 5 equal sections, and we've spun them 50 times. We've spun the spinner 50 times. So what's the experimental probability of landing on blue? So the experimental probability of landing on blue, so we're interested in blue, and that's 15. Divided by the total number of trials that we did, which is 50. Right? You can divide this by 5 on top and bottom and get 3 out of 10. So we have roughly a 30% chance of getting blue according to our experimental probability. Now, which color appears the most often in this experiment? Well, out of all of these, blue is the one that appears the most often. And once we've done enough trials of this, we might find out that in fact blue has the least likelihood of occurring, or we might find that it just scales up and stays the most likely event. What this ultimately means is we have a better idea of each of these outcomes' probabilities of occurring, because we do not know for certain what the probability of each one is. Now obviously if there's a spinner and it is just all equal amounts of area of the wheel, then yes, we're going to find that we're going to have an equal distribution of outcomes. But that's not necessarily what this is for. This is all for things that don't have an easy way of assessing whether or not there is an exact probability. Alright, that's it for this video. Hope it was helpful, and I will see you in the next one.